Okay, guys, welcome back. Okay, so in this lecture, we're gonna now head on to the next chapter, which is actually related to physical quantities, but like a bit more advanced level of physical quantities. All right, so now basically physical quantities, which I told you in the previous lectures, are actually any quantities or any property of a measure of a material which can be measured is known as a physical quantity. Okay, the property that is measurable, that can be measured, is known as a physical quantity. Physical quantities broadly can be divided into two categories. We've got scalar physical quantities and vector physical quantities. Okay, what do we mean by scalars and vectors? Let's define them first. Okay, so scalars are those physical quantities which only have magnitude and unit, whereas vectors, in addition to magnitude and units, vectors also have magnitude and units, but in addition to these, vectors also have a specific direction. Okay, so basically what's the basic difference between the scalar and vector is that vectors contain directions, whereas scalars, they lack direction. Scalars are independent of direction, whereas vectors are dependent on directions. Okay, these are the direction dependent. So this means that if okay, what do we mean by magnitude? Magnitude is just the number. Okay, the number. For example, and unit, you guys know what units are, the SI units basically, which I usually use. So basically scalars, I'll just give you an example. Scalar, for example, mass is considered a scalar quantity. Okay, so what do we mean by it's a scalar? Well, actually mass has a unit of let's say if I take a value for mass, it's 5 kg. Okay, there is no reference to direction, but it's just a number and a unit. Okay, so that's why it's a scalar quantity. Whereas if you talk about vectors, vectors are actually specific to directions. Okay, if the direction of the vector quantity changes, the vector quantity also changes. Okay, so basically the direction has to stay constant as long as you want the vector to stay constant. If the direction changes, the vector changes. All right, so now I'll just give you a few examples of both scalars and vectors. Okay, so scalars in our syllabus are actually distance is a scalar quantity. Okay, length, which is also a distance, actually length. Well, length can be of two types. It can be distance or displacement, but okay, I'll just erase out the length. Length can be of two types. Let's not keep the length over here. Length, although if just length is mentioned, it's a scalar quantity. Okay, speed is a scalar quantity. Time is a scalar quantity. Mass is a scalar quantity, as I told you earlier. Whereas if you talk about vectors, vectors include displacement is a vector quantity. Speed is a scalar quantity, right? Velocity is a vector quantity. Acceleration is a vector quantity. Okay, and force, let me give you another example. Force is also a vector quantity. All right, so now these quantities that I've mentioned over here, let's talk about them one by one. All right, so first of all, what's the difference between distance and displacement? The very first difference that you guys might have already guessed is that distance is a scalar quantity, whereas displacement is a vector quantity. Okay, this column over here mentions all the vector quantities, and this column over here mentions all the scalar quantities. Now, guys, remember, first of all, in order to understand the difference in between distance and displacement, we need to define them. So distance is actually the length of a path that is covered in between 2 points. Okay, this is the length of a path between 2 points. Okay, now, for example, if you take these 2 points, this, let's assume this to be point A and this to be point B, the lengths can be different. It can be all the way from over this path, or it can be over this path, or you can travel from A to B using this path, and or any path that you travel to reach from A to B. If you measure the length of that path, that length is going to be considered as distance. Now, it doesn't matter what direction you measure it from, or it doesn't matter in what direction you go, the length is still going to be considered as the distance. For example, if this is point A, and as you go from point A towards point B, this is the length, okay? Now, if you return back from point B to, let's say, this point C, and you wanna, this was, for example, this was length 1 and this is length 2, and you want to consider, or you want to measure out the distance from A to C, the distance is going to be L1 plus L2, and there is no reference to direction. You can measure it in any way you want, okay? You can measure it from here, or you can measure it from here, or you can measure it in this way. It doesn't matter. But now if you talk about displacement, what is displacement? Displacement by definition, okay, I'm writing down the definition of displacement. This is actually important, okay? Displacement, in the definition of displacement, displacement is actually the shortest directed, okay, if you look at the definition, there is the word directed in it. Directed is referring to the direction, correct? Okay, so the shortest directed distance between 2 points is known as, between 2 points is displacement, okay? So now if you take the A and B points example again, for example, this is point A and this is point B, and the shortest possible distance that you can measure is directly from A to B, right? The straight length. This length is going to be considered as displacement, and you always have to measure the displacement with respect to a starting point. This point A is considered as the starting point in this case, okay? And you've measured displacement from point A to point B, okay? So displacement, if you want to, for example, the length of this is, let's say, 5 meters, okay? The length of this path is 5 meters, and you want to give the value for displacement. So guys, remember, on top it's always the north direction, on the right hand side is always the east direction, right? So now if you want to give the value for this displacement from A to B, so you have to mention it in the following way. It's 5 meter northeast of B, okay? So what have I done over here? I've given the number, I've given the unit, and I've also given the direction. And to be more specific, you can also calculate this or measure out this angle theta from the horizontal. So you could also give it in with reference to the angle by saying that it's 5 meter, let's say it's theta angles from the eastern side, 5 meters theta degrees from the east. So again, this theta degree is also referring to the direction of this particular displacement from A to B. Okay, this is giving us a displacement from point A to point B. But now if you talk about the distance in between these two particular points, this is point A, this is point B. Now, if you want to talk about displacement, is from point A to point B directly, the shortest possible distance, the shortest possible directed distance, okay? It's from point A to point B. But if you want to talk about distance, it can be any other path, and it can be any path actually, okay? This path can also be the distance, this path can also be the distance, this path can also be the distance, okay? It doesn't matter what direction you go to, okay? Only the starting and the ending point matters, and the path that you cover from these 2 points, all of these white paths, they can be different values for distance, but displacement is actually the shortest possible distance in between these 2 points, okay? Hope this gives you an idea of what scalars and vectors are. Okay, so scalars are independent of direction, whereas vectors are direction dependent. Okay, so now after we've talked about the scalars and vectors, basically the distance and displacement, to talk about the difference between speed and velocity, we'll talk about the difference between speed and velocity in the upcoming lecture. Thank you so much.